हेलो फ्रेंड्स, कैसे हैं आप। माय नेम इज़ शुभम गुप्ता और मैं आज आपसे ये शेयर करना चाहता हूँ कि आप किस तरीके से अपने कॉलेज में प्रेजेंटेशन दे सकते हैं। रिसेंटली मैंने अपने सेकंड सेमेस्टर में अभी अभी रिसेंटली प्रेजेंटेशन दी है, तो मैं आप शेयर कर सकता हूँ कि आप टॉपिक कौन सा ले सकते हैं। तो मैंने अभी रिसेंटली टॉपिक लिया था जाइंट मीटर वेव रेडियो टेलीस्कोप पर। सो मैं हमारे यहाँ तो ऐसा है कि टोटली आपको मतलब पूरा इंग्लिश में ही मतलब एक्सप्लेन करना होता है, तो मैं वही ट्राई करता हूँ एक्सप्लेन करना। ठीक है, सो लेट्स स्टार्ट। गुड आफ्टरनून प्रोफेसर एंड माय डियर फ्रेंड्स, माय नेम इज शुभम गुप्ता एंड टुडे इन दिस टॉक presenting on the behalf of the scientists and engineers who built and commissioned the Giant Metrewave Radio Telescope, or we call GMRT. We have given a brief outline of the instrument and some of the recent scientific results obtained from it. Before going to start the GMRT introduction, let's look at the history behind it. In 1928, the USA Telegraph Service across the Atlantic experienced the high interference. Messages sent using the radio signal get corrupted by any other kind of noise, much like a hills of transistor set. Firstly, uh, what is the radio wave actually mean? A radio signal or a radio wave are a form of electromagnetic wave having both electric and magnetic components, just same as the light rays, ultraviolet and infrared. The only differences is in the wavelength of the wave actually. Okay, so come to our point. A young scientist named Carl Jansky is put on the job of investigating these disturbances. In his search, he builds a special device. What he discovered will forever change how we study the cosmos. So, Jansky announced that the signal it received were coming from the Earth's home galaxy to the Milky Way. This was a stunning discovery. It suggested that the celestial objects were actually a radio source emitting radio signals that could be picked up by the receiver on the Earth. Unfortunately, Jansky himself was not unable to continue what he started because of the outbreak of the World War II. So the man was picked up by the homemade radio operator and engineer called Grotto Ribber. Ribber embarked on an ambitious project to build the first ever radio telescope in his own backyard. Now, when we see the images captured by the optical telescopes, which I share, yeah. So, the images captured by the optical telescopes, most of us are familiar with it. Even a amateur astronomer would recognize that this is the sun, this is the Jupiter, this is the Saturn, this is the Milky Way. But what happened when we look through the radio telescopes? That the same objects reveal a completely new character. In this radio universe, the same objects appear more active, changeable, and violent than their optical avatar. Through the 1940s, 50s, and 60s, many new objects were discovered by the radio telescopes, such as pulsars, quasars, and exotic radio galaxies, which I show in this screen. So, these early discoveries was closely followed by the young student I'm calling in the post-independence India. His name is Govind Swarup. So in 1963, okay, so this is the Govind Swarup picture. So actually, the idea of the giant meter wave radio telescope was given by the Govind Swarup. Okay, so actually, in 1963, the Govind Swarup handpicked by Homi Bhabha to form the India's first radio telescope group at the Tata Institute of Fundamental Research. 80 kilometers away from the bustling city of Pune, in the open field of district Khodad, and scroll across the 25 kilometers, is the Giant Meter Wave Radio Telescope, or we call GMRT. This is the realization of Indian radio astronomy most ambitious dream. The GMRT is the collection of 30 massive dish and antenna which collect the radio signals coming from the far away objects and the phenomena in the sky. It is the world's most sensitive telescope to capture the radio signal measured in meter-long wavelength. Actually, these antennas are spread over 25 kilometers in diameter, with about half the antennas randomly localized in the central 1 square area and the remaining ones along the 3 14 kilometers arm of an appropriate Y configuration. The longest baseline is about 26 kilometer and the shortest about 100 meters. So the dish has 16 parabolic frames which give the basic shape, and the reflecting surface consists of stretch mesh attached to the rope trusses, or we call smart. So this is the smart technique. So in this smart technique, the wire mesh size is matched to the long and large wavelength of operation and varies from 10 millimeter into 100 millimeter inside and 20 millimeter into 20 millimeter in the outer one, a third of the dish surface, one third of the dish surface. Actually, it is cheap, light, and because the mesh is permeable, the dish are less likely to move in the wind. Okay, so the configuration of the dishes contribute to the powerful process called aperture synthesis. By the uh, technique aperture synthesis, with it the scientists produce radio images with incredible resolution. Now let's look about the correlator, the digital backend in the section of GMRT which deals with the digital conversion, manipulation and storage of the analog signal coming from the baseband system. Actually, the signals from the antenna after going to the baseband actually uh, is actually analog in the form. So this signal needs to be converted into digital form so that it could easily be worked upon using digital signal processing. The signal after being converted into digital form is processed through correlator, and that correlator named FX correlator, that actually FX correlator uh, that's used to generate the cross amplification by the use of amplifier and the phase information among the 30 antennas to synthesize the stock parameters. But one question may arises in your mind that during the receiving the radio signals from the far objects, there will be a human interference such as mobile signals, television signals, and even high voltage electricity may interfere or maybe attenuate the information coming to the GMRT. But the scientist was aware from it, so that they had choose the noise free zone actually. uh, so the that noise free zone without any mobile signals and any kind of interference. Yeah, that's the mind of the scientist. So from here, even the weak radio signals are strengthened by the amplifiers and sent by optical cables to the GMRT supercomputing digital system. That digital system process the radio signal, but they do not give to the astronomical sorry actually they not giving the visual image to the astronomers. Yeah, instead of that the images of the uh, that they range to the number related information getting from the uh, far away objects. So what happening is there actually that visual image of the celestial objects are in the realms of number. So uh, now it go to the astronomer software which we call special software. That special software convert the numerical data into the image of radio emission from the source. So uh, uh, these are some functioning process occurring in the GMRT. So now let's see some recent scientific results obtained from the GMRT. So GMRT has been used to observe a variety of astrophysical objects such as sun, planet, pulsars, H2 region, galactic and extragalactic supernova remnants, quasars. So, but now let's see some brief observations solar observations that figure 5 explaining. So this solar observation using GMRT, actually in this when we are saying a sun is being observed by using GMRT in all the bands, that figure 5 shows a variety, uh, not a variety actually, it's a recent 150 megahertz observation of the radio counterpart of the coronal hole. Actually, I want to explain you what is the coronal hole actually mean. A coronal hole are the outer part of the sun which is colder, darker and has lower density. It is constantly changing and reshaping because the corona is not uniform. So the figure 5 captured by the GMRT is useful for studying the structure of coronal hole. So the next is to finding the new pulsar using GMRT. Firstly, what is pulsar actually mean? Okay, so to understand what is a pulsar, uh, before going to explain pulsar, we must understand what is a neutron star. Okay, so actually, if the mass of the dying star is more than the Chandrasekhar limit, which is about 1.4 times the mass of sun, but less than the another limiting value, which is about 3 times the mass of sun, that dying star become neutron star, and the pulsar is that rotating neutron star. So the new pulsar has been discovered in the globular cluster which name NGC 1851. So actually NGC stand for New General Catalog, which contain 7,840 objects including galaxies, star clusters, nebula and many more. And this NGC 1851 is one of them. This is the new pulsar having eccentricity is 0.88. So the the new GMRT result is the detection of SGRA. Actually, this SGRA, what is that figure actually? Oh, this figure 7 is SGRA uh, images. So SGRA stand for Sagittarius A. Okay. So actually it is the bright and compact astronomical radio source at the galactic center of Milky Way. So the galactic center means subdivision of the center of Milky Way galaxy, we may calling. So the GMRT study shows that it lies in the front of SGRA West H2 region. H2 region means actually H2 region consists of ionized hydrogen. Okay, so this region exists only in the hot stars. Actually this was the first detect at 635 megahertz. So the new discovery of the GMRT is to the study of dwarf dark galaxy. This is the picture of the dwarf dark galaxy. That firstly I'm going to explain what is a dwarf dark galaxy. Actually the story is that if the mass of the dying star is less than the Chandrasekhar limit, which is about 1.4 times the mass of sun, then the star turns into white dwarf. Okay, so the study of the dwarf irregular galaxy named NGC 3741 by making an integrated H1 map showing that H1 gas disk is about 8.3 times the Holmberg radius. So the next discovery is radio galaxies and quasar. Okay, so I'm going to explain that GMRT images of the radio galaxies named 3C315 as shown in the figure 10, typically X shape you are seeing in the picture on the screen, that X shaped has a redshift which is less than 1.3 were formed. Now the H1 observation of the superwind galaxy called NGC 1482 with the GMRT shows two blobs of radio emission on opposite edge of galaxy that superposed on a Chandra X-ray image. Actually, Chandra X-ray image actually captured by the Chandra X-ray laboratory. Okay, that's actually observatory used by the astrophysics. Okay, to visualize the images. So these are some references which I use to make this presentation. ओके, थैंक यू. सो ये थी प्रेजेंटेशन. इस टाइप से मैंने दी थी अपने कॉलेज में भी 2 दिन पहले. तो आई होप कि आपको ये समझ में आया होगा और आप भी इस तरीके से दे सकते हैं. बस मेरा एक ही मोटिव था कि इस तरीके की प्रेजेंटेशन मतलब ऑनलाइन मोड से हम लोग अपने कॉलेज में देते हैं. ठीक है, तो जो लोग न्यू हैं उनके लिए जो है काफ़ी यूज़फुल है ये वीडियो. सो थैंक्स फॉर वॉचिंग.